In today's video, we'll look at the basic formulas for differentiation and integration side by side. We'll compare the formulas for differentiation and integration. Let us start the video. Formula number 1, d dx of x equals 1, and for integration of x dx equals x squared by 2 plus c. So for differentiation of x, the result is 1, and for the integration of x, the result is different, which is x squared by 2 plus c. Formula number 2, d dx of cx equals c, where c is a constant, and for integration of cx dx equals cx squared by 2 plus c. So if there is a constant and x, the differentiation result is only the constant, but the integration result is different. Constant times x squared by 2 plus c. Formula number 3, d dx of c is a constant, equals 0. When there is just a constant, the differentiation of that constant equals 0. But for integration of c dx equals cx plus c. So the results for differentiation and integration is different for a constant. Formula number 4, d dx of cx plus d equals c. Only the coefficient for the x remains in the result for differentiation. For integration of cx plus d dx equals 1 by c times cx plus d whole square by 2 plus c. So this is the difference between differentiation and integration for a function like cx plus d. Next, formula number 5, d dx of xn equals nx to the power n minus 1. But in case of integration of xn dx equals x to the power n plus 1 divided by n plus 1 plus c. For example, if we have d dx of x4, we can write it as 4x to the power 4 minus 1 or 4x cubed for differentiation. But for integration, if we have integration of x4 dx, we can write x to the power 4 plus 1 by 4 plus 1 plus c, and we get x to the power 5 by 5 plus c. So this is the difference between differentiation and integration in terms of functions like x to the power n. Formula number 6, d dx of x square equals 2x. Similarly, for integration of x square dx equals x cubed by 3 plus c. Formula number 7, d dx of square root of x equals 1 by 2 square root of x. For integration of square root of x dx equals 2x times square root of x divided by 3 plus c. Formula number 8, d dx of 1 by x equals minus 1 by x square. But for integration of 1 by x dx equals log ex, means natural log x plus c. So this is the difference between differentiation and integration for 1 by x. Formula number 9, d dx of 1 by x square equals minus 2 by x cube. And for integration of 1 by x square dx equals minus 1 by x plus c. So this is the difference for 1 by x square for differentiation and integration. Formula number 10, d dx of ex equals ex, and formula number 10 for integration, the integration of ex dx equals ex plus c. This formula is quite similar for differentiation and integration. Formula number 11, d dx of cx c to the power x equals c to the power x times log ec, means natural log of c. And for integration, integration of cx dx equals c to the power x by natural log of c plus c. For example, we have d dx of 3x equals 3 to the power x log e3. This is the differentiation result. And for integration, integration of 3x dx equals 3 to the power x log e3 plus c. So this is how we can write this formula for differentiation and integration. Formula number 12, d dx of log ex equals d dx of ln x. We can write log ex as ln x equals 1 by x. Similarly, integration of log ex dx equals x times log ex minus x plus c. So this is the difference for log ex between differentiation and integration. Formula number 13, d dx of log c base x equals 1 by x times 1 by ln c or log ec. For integration, we have integration of log c base x times dx equals x log c base x minus x by log e base c plus c. Here the base for the log is c and here the base for the log is e. That means log ec we can write as ln c. So this is the natural log for c. Formula number 14, d dx of sin x equals cos x. Similarly, for integration, integration of sin x dx equals minus cos x plus c. So the difference between the results is there is plus sign before cos x and there is a minus sign before cos x in integration. Formula number 15, d dx of cos x equals minus sin x, and for integration of cos x dx equals sin x plus c. Here also the difference between the signs, sin x has minus sign in differentiation, but in integration sin x has plus sign. Formula 16, d dx of 10x equals sec square x, but in case of integration of 10x dx equals minus log e base absolute value of cos x plus c. We can write this as equals log e base absolute value of sec x plus c. So if we write cos x, absolute value of cos x, we have a minus sign in front, but when we write in terms of sec x, absolute value of sec x, there is a positive sign. So we have to see the difference here. Formula 17, d dx of cot x equals minus cosec square x, but in case of integration of cot x dx equals log e base absolute value of sin x plus c equals minus log e base absolute value of cosec x plus c. When there is a sin x, there is a plus sign in front, but when there is a absolute value of cosec x, there is a negative sign in front. Formula 18, d dx of sec x equals sec x times tan x. Integration of sec x dx equals log e base absolute value of sec x plus tan x plus c. Formula 19, d dx of cosec x equals minus cosec x times cot x. Integration of cosec x dx equals log e base absolute value of cosec x minus cot x plus c. We can express this result in terms of tan x by 2. We can write log e base tan x by 2 absolute value of tan x by 2 plus c. So we can express integration of cosec x dx in these two ways. There are two special formulas for integration. Formula number 20. Integration of tan square x dx equals tan x minus x plus c. Formula 21. Integration of sec square x dx equals tan x plus c. We have multiplication and division formulas for differentiation. Formula number 22. d dx of fx times gx equals d dx of fx times gx plus fx times d dx of gx. So these functions are multiplied. So the result will have differentiation of the first function times the second function plus first function times the differentiation of second function. So this is how we can express the multiplication rules for differentiation. Formula number 23, d dx of fx by gx. Now the functions are divided. We have equals d dx of fx times gx minus fx times d dx of gx divided by gx whole square. In terms of multiplication, there is a plus sign. In case of differentiation, there is a minus sign in between, and we have to divide by the denominator function, which is gx whole square. So these are the basic formulas for differentiation and integration, and we have seen the comparison between the formulas. This is the end of this video. Thanks for watching the video.